Find the maximum number of points that lie on the same line in a given set of 2D points. The input to the problem is an array of 2D points represented as integer pairs. The output of the integer representing the maximum number of points that lie on the same line. For example, given the following set of points 1, 1, 2, 2, 3, 3, 4, 4, the maximum number of points that lie on the same line is 4. Since all these points lie on the same diagonal line, another example would be a set of points 1, 1, 2, 2, 3, 1, 4, 2, and 5, 1, where the maximum number of points that lie on the same line is 3. Since the first, third, and fifth points lie on the horizontal line and the second and fourth points lie on the diagonal line. To solve this problem, the code iterates through each point and for each point calculate the slope between it and all the other point that comes after it. If two points have the same slope with respect to the current point, it means that they lie on the same line. The code keeps track of the counts of points that have the same slope and update the maximum count of points that lie on the same line for each point. Finally, return the maximum count of points found across all points. The max points method finds the maximum number of points that lie on the same line in a two-dimensional plane in a given set of arrays. In this case, the point array contains these 3 points 1, 1, 2, 2, and 3, 3. These points all lie on the same line with a slope of 1. So the expected output is 3, which is the maximum number of points that lie on the same line. The max points method starts by initializing a variable max to 1, which represents the global maximum number of points that lie on the same line. This is because there is a set of at least 1 points on any line, so the maximum value of max is 1. Next, the method iterates through each points in the points array using a nested loop. For each point, the method creates a map that will store the number of points that have the same slope with respect to the current points. The method then initializes a local variable local max to 1, which represents the maximum number of points that lie on the same line with respect to the current point. This is also set to 1 because the current point is always on the line with itself. The method then enters a nested loop that iterates through all the points that come after the current point in points array. For each of these points, the method calculates the slope between the current point and the other point using the getSlope method. The slope is then added to the map object and its count using the put method. If the slope is already in the map, the count is incremented by 1 using a get or default method. After processing all the points with respect to the current point, the method updates the local max variable to be the maximum of its current value and the count of the slope with the maxmost point. Finally, the method updates the maximum variable to the maximum of its current value and the local max variable. This is done because local max represents the maximum number of points that lie on the same line with respect to the current point, and we want to find the maximum number of points that lie on the same line among all the points. After all points have been processed, the method returns the max variable, which represents the maximum number of points that lie on the same line in the entire points array. In this case, the point array contains 3 points 1, 1, 2, 2, and 3, 3. The method starts by processing the points 1, 1. It calculates the slope between 1, 1 and 2, 2, which is 1, and it adds to the map object. It then calculates the slope between 1, 1 and 3, 3, which is also 1, and it adds to the map object. The count for slope E1 is now 2 in the map, so local max is updated to 2. The method then processes the point 2, 2. It calculates the slope between 2, 2 and 3, 3, which is 1, and adds it to the map object. The count of slope 1 is now 3 in the map, so local max is updated to 3. This is the final value of local max for this iteration of the outer loop, and it is also greater than the current value of max, which is 1, so the max is updated to 3. The method then proceeds to process the remaining points the same way, but since there is no more point, In the point area, the method return the value of max, which is 3. This is the output.